Now, I think trig gets a really bad rap because the first thing you learn is you learn the SOHCAHTOA and you learn a little trick to remember it, but you don't get an idea of what trig is actually used for. And I'll just complete these definitions quickly and then I'll talk about that. So, I want you to think about, in mathematics we love this idea of a triangle, Mitch. We love these triangles and we're obsessed with this guy called Pythagoras. Why is that? Well, there's a couple of reasons that I found. The first one is, when you think about the real first kind of applications of trigonometry, it wasn't this right-angled triangle that we're so used to seeing. The first kind of instances were actually in navigation. So if I want to get from one point to another, and back home, I've created this kind of spherical triangle, and that's really important in order to understand the lengths and angles and the relationships with each other. But obviously now we're not doing so much navigating across the seas, but we do play a lot of games, don't we, on our phones, on our computers, and those games and computers, they need to model the real world in some way. And these trigonometric ratios help us do that. There's also a beauty in it though. Triangles are the simplest polygons, or the simplest shape you can make with straight edges. What does that mean? Well, it means that every other shape can be made up of triangles as well. And not in just shapes, but also these guys' faces, right? Have you guys seen a picture like this before, anywhere?
Yeah.
Where, Keaton?
Oh, when you hold the Snapchat.
Good, right. When you hold the Snapchat face filter swap thing, right, it breaks your face down into these little different triangles to understand the different features of your face so you can identify what it's actually looking at, where your eyes are, where your mouth is. And last but not least, my favorite one, Cassie, you asked me why do we have music up here? This is probably the last place you'd expect to see trigonometry. But for those of you who do physics, you know that the sounds that we hear, they can just be broken down into waves. Why is it that when we play like a C, E, G chord, anyone play music here? Actually,
because it hits your ears a different way.
Yeah, well, when you play like
Different
a
waves.
C, E, G chord, it's like a major chord, or when you can play a minor chord and that creates a sad tone, exactly, yeah. So when we actually break these notes down into these waves, we can actually realize that they model these trigonometric relationships. If I change the slider, you can see that as it gets kind of skinnier, right, it gets to a higher pitch, and then I go back down again, and then it stretches out. And we'll look at this a bit later, but a certain amount of ratios of these waves, right, create a really nice sound, like your next pop hit. But if you create a different ratio of them, it will sound like a 5-year-old piano recital, something not so good, right? So when you're finding these unknown angles and sides, realize there's actually a greater, bigger picture and purpose to actually doing these operations, okay?